Hi class. So what we're going to do, we're going to talk about solution and concentration. Now, we've talked about solution and concentration in Chem 1A, and we're going to continue talking about it in Chem 1B. Now, a little reminder, what's the solution? You've done this many times. You've taken salt, which is NaCl, and then you add it to water. When you add salt to water, what happens? The salt disappears, right? The salt dissolves in water and you form a solution. If you've never done this before, go do it right now. It's gonna change your life. It's pretty cool. So you add salt to water, the salt dissolves, and you end up having a homogeneous solution. So the salt, the NaCl, is a solute, water is my solvent. When the salt dissolves in the solvent and it has a homogeneous solution is formed. So far so good. Okay. Now, when you form a solution, the next thing to think about is what is the molarity of this solution? What is the concentration of this solution, right? Did you add too much salt? Do you need to add more salt? That is concentration. You deal with concentration on a daily basis. You just don't think about it. So sometimes when you get your coffee and your coffee is too strong, what do? You add milk to it, right? Or you add half and half to it. The way I like my coffee is like this much half and half and a splash of coffee. But what are you doing? You're changing the concentration without thinking about it. If you drink tea and your tea is too dark, what do? You add water. So what are you doing by adding water? You're changing the concentration. So you deal with concentration all the time. You just don't think about it. Next time I want you to think about it. Now, there are many different units of concentration, but chemists, we love molarity. We love molarity. Why do we love molarity so much? We love molarity because chemical reactions are balanced for moles, right? When you balance the chemical reactions, the coefficients are the mole ratio. We teach you in Chem 1A, the coefficients are the mole ratio. So we balance chemical reaction for moles, so we care so much about moles, so we love molarity. But normal people don't care much for molarity, right? Biologists, they have their own units, physicists, they have their own units, nurses, they have their own units. So different people, they use different units of concentration. But we love molarity. Now, what do we need to do? Now we're stuck having to convert from one unit to another unit. Now, that's what we're going to focus on. Trying and teaching you how to convert between different units of concentration. I emailed you guys a handout, and that handout has different units of concentration, and it's good to know the different units, but mostly we're going to use molarity because we love molarity. Now, let's do a practice problem to see how we change the units for the concentration and why we would do that. Let's say we're going to go to lab, okay? And in the lab, there is a bottle, okay? We're going to go to lab, and in the lab, there is a bottle of sulfuric acid. And in that bottle, it says 85% by weight H2SO4, which is sulfuric acid. And also it says the density of this solution, it says the density of this 85% sulfuric acid is 1.46 grams per ml. Okay, so I'm going to go to lab, and in my lab there is a bottle of sulfuric acid. It says 85% by weight. Now, that's pretty concentrated, isn't it? That's pretty concentrated. Now, it's cheaper to buy things that are more concentrated because you can buy them concentrated and you can dilute it and you can save a lot of money. When I was in grad school, I used to buy 2% milk for the same price of the 1% milk and then add water. Now I have double the milk for the same value. That was not a good idea. It tasted disgusting, but it saved me money. So again, we sometimes buy things that are concentrated because they're cheaper and they're easy to store, then now we have to dilute it. So what I want in lab, so this is what I have in lab, but what I want, I want 100 ml, I want 100.0 ml of 1.00 molar sulfuric acid. So I have a bottle, it does not have a concentration on it, it says 85%, percent is usually was by weight percent, so I have a different unit of concentration on it, and then what I want 100 ml of 1.00 molar sulfuric acid. Hopefully you're clear about the question. Now what I'm going to do, how am I going to make this solution based on what's given to me? So what do I have to do? When you read this question, what you have to do, what the unit that is given to you is percentage, is mass percent, right? So I have a unit that is mass percent, and I have to convert that unit to molarity, because I care about molarity, and then I probably have to dilute it to get to the molarity that I want. Okay, so again, this bottle in lab, it gives you a different unit. It's a mass percent unit. So it's 85% my mass, and it's really concentrated. What I want is 100 ml of 1.00 molar sulfuric acid. So I have to somehow convert the unit and then dilute it to get to what I want. You gonna follow me so far? Now, I said usually percentage or mass percentage. Usually percentage, if they don't tell you, just assume it's mass percentage. So it's 85% by weight. That means it's grams of sulfuric acid over the grams of the entire solution, right? Grams of sulfuric acid divided by the grams of the entire solution times 100, that give you the percent, right? Okay. But what we want, the unit that we want is molarity. Molarity is, you notice, molarity is moles over liter, right? Molarity is moles of, in this case, moles of the solute, H2SO4, over liters of solution. Molarity is moles per liter. So this is the unit that we have. This is the unit that we want to get to. Okay. All right. So if you look at this, I'm trying to go from grams of sulfuric acid to moles of sulfuric acid. And I'm trying to go from grams of solution to liters of solution. You know how to do this. How do you go from gram to moles? Tell me, even though I can't hear you, tell me anyway. How do you go from grams to moles? You know this. To go from gram to moles, you use molecular weight. Now, how would you go from grams of solution to liters of solution? That's a little bit newer. To go from grams to volume, to go from mass to volume, you use density. You use density, okay? I want to make a little side note here for you. Remember that. Every time they give you mass, but you want to convert it to volume, what you use density. This is a part is new. I want you to remember that. To go mass to volume, what do you need? You need density. Okay. Are we good so far? So molecular weight, density, and we can convert percentage to molarity. Now, one thing that I teach my Chem 1A class all the time is that if you learn nothing from me or from chemistry, learn to cancel out, because that's the best way to do it, when you cancel things out. Okay, so let's cancel things out and turn that 85% by weight into molarity. Okay, let's turn that 85% unit into molarity unit that we want. So it says you have 85%, right? Percentage is not an amount. Percent is a ratio. I want you to remember that. That percent is not an amount. Percent is a ratio. So what I like to do, I like to just make up numbers to get to that ratio. So I can say that if you have 85% by weight, can I say that if I have 85 grams of H2SO4 in 100 grams of solution. Can I say that? Why not? I can say that, right? Because that would be 85%. 80 divided by 100, that would be 85%. So I can say that. So if I have 100 grams of solution, 85 grams of that is going to be sulfuric acid. Okay, and remember what I want to end up with is moles per liter, right? That's what I want to end up with. I want to end up with moles of the H2SO4 over the liters of solution. This is what I want to end up with. Okay, so looking at that, I know I don't want the grams of H2SO4. I want moles, because again, what I'm ending with, let's pay attention to this part. What my end goal is moles of H2SO4 over liters of solution. Let me actually write it down nicely. So what my end goal is moles of H2SO4 over liters of solution. Because that's molarity, yeah? That's my end goal. I'm going to try to cancel it out to get to that. So I don't want grams. Gram is going to go over here. I want moles. Is going to go on top. Moles of H2SO4. And we talked about this. How do you go from gram to moles? You use molecular weight. 1 moles of H2SO4 is 98 grams. You follow me so far? Okay. Again, to go grams to moles, use molecular weight. And don't forget, molecular weight is always for 1 mole. Okay, so I have the moles of H2SO4, which is what I wanted. That's great. Now, I don't want grams. I don't want grams. What I want is liters. And we said to go from mass to volume, you need to use density. So, I'm going to come over here. Okay. Where's my eraser? Oh no, I lost my eraser. I'll find it soon, hopefully. Oh, right here. Now, I don't want grams. It's going to go here. What I want is volume. I'm going to go with ml. Okay? How do I go from mass to volume? How do you go from gram to volume? You use density. And the density was given to you. So the density was 1.46 per 1 ml. Okay? So the density is always again per 1 ml. So now the grams can cancel out, and what I have milliliters. That's good. It's almost good. What do I need? Molarity is moles per liter. So the last thing to do is convert the milliliters into liters. I don't want ml, goes on top. What I want is liters. 1 liter is 1,000 milliliters. Okay, so now the ml also cancels out, and what I end up with liters. So what I have moles of H2SO4 divided by liters of solution, which is the molarity that I wanted. Okay, so what I end up getting 12.6 molar, which is moles per liter. You guys follow that? Okay. Again, remember, all you're doing, you're canceling it out. You didn't want grams, you want mole. Molecular weight, you can turn the gram into moles. And don't forget, reminder of Chem 1A, remember this. To convert grams to moles, molecular weight is always for 1 mole. Okay? And then what I had to do, I had to turn gram into volume. I can do that using density, and the density again is for 1 ml. The density is for 1 ml, and I'll just convert ml to liter, and I'm good. I have the molarity that I want. So now I know that this bottle, when it says 85% by weight unit, which I don't like that unit, I like molarity. I'm one of the not normal people, right? It's 12.6 molar. Now what do I need to do? I need to dilute it. So I know the bottle is 12.6 molar. So I know the bottle is 12.6 molar. So when they say you have 85% by weight, I know that's 12.6 molar. Now I don't want that. I want 100 ml of only 1 molar. So the bottle is 12.6 molar, but what I want only 1 ml molar solution. What do? I use every time you want to change the concentration, what is it? What's the equation you use? You remember it from Chem 1A. The equation you use is N1V1 N2 V2. Good job. Okay, I'm going to write this down to make sure we're on the same page. So the bottle is 12.6 molar, but what I want 1.00 molar. So what I have to do, I have to do dilution. So what I have to do dilution. And every time you have to do dilution, the equation for dilution is N1V1 equals N2V2. N1V1 equals to N2V2. That is the formula for dilution. Okay. Now, what is my initial concentration? My initial concentration is 12.6 molar. What is my final concentration? My final concentration that I want is 1.00 molar. You follow me so far? How much of the final concentration do I want? I want 100.0 ml. So now I can figure out how much of that bottle I need to take. What I get for X, which is my V1, the X is going to be 7.93%. 7.93 ml. Oh, what did I say percent? I don't know. 7.93 ml. Okay, you guys are good so far. Now, this is a lot of review from Chem 1A, so remember that. So every time you do dilution, so we figure out that on the bottle that says 85% by weight, that bottle was 12.6 molar. But what I want a 1 molar solution. So I have to do dilution. Every time you do dilution, is N1, V1, N2, V2. I plug it in, and also as you remember, the units don't matter as long as you have the same units on both sides. As long as it is ml, ml, molar, molar, we're good. All right, now, what does this number mean? So what does this number mean? How am I going to make this solution? How am I going to make my 100 ml solution of 1 molar sulfuric acid? How am I going to make this? That also matters in lab, right? Calculation is part of it, but how am I going to make this? Let's make this solution together. You got this down? Okay, let's make this solution together. So, we've figured out percentage to molarity. We know the numbers. Now the question is, how are we going to make this in the lab? Sorry about that. Trying to wake you up. Here's how I'm going to make this. I'm going to use, I really suck at drawing, so hopefully you guys. This is a volumetric flask. When you see volumetric flask in the lab, it looks nothing like that. I'll try to do better. So I'm going to use a 100 ml volumetric flask. So if you remember volumetric flask is not graduated. It has a fixed volume. So if I use a 100 ml volumetric flask, the only volume that I can measure is 100 ml. And the reason it's nice to use volumetric flask is because this is good to 2 decimal places. This is good to 2 decimal places. So it's very accurate. So I'm going to take a volumetric flask. Then what would I add to this? This is what you would do in lab. You would add 7.93 ml of 12.6 molar solution, right? Because we decided that that's how much we need to take. We would take 7.93 ml of 12.6 molar solution, which is our bottle in lab. So I would take 7.93 ml of that bottle that I have in lab, and then I would add water. Now, you could calculate the water or just add water to the mark. That's the best way to do. Add water to the mark. Because remember, the final volume should be how much? 100 ml. When we did M1, V1, M2, V2, the final volume was 100. So the final solution should be 100. You can calculate how much water you need, or you can just keep adding water until you reach the 100 ml mark. So far, so good. And then you shake it really good, and that's it. You're going to have 100 ml of 1 molar sulfuric acid. How do you guys feel about this? Okay? Yeah. So remember, you may have to do this all the time. You may have a different unit of concentration, and you can convert it to molarity, which we like, and then we can do dilution to figure out how much we need. All right, so that was the one thing that we're gonna do practice problems on, learning to convert between different units in lab and making the solution in lab. Now the second thing that hopefully this one is a review that you got to remember for me is stoichiometry. Yeah, you thought you were done with that. Nope, you're still gonna do stoichiometry. Stoichiometry. Now there's two things about stoichiometry that I want you to remember, okay? Stoichiometry, one of the things that we did was figuring out limiting reagent. So remember the limiting reagents problem. And the second thing about stoichiometry, I'm hoping you remember, was that when we do stoichiometry, what really matters, and the way I teach this in my Chem 1A, I give it a hashtag just to give it the importance that it needs. Hashtag mole ratio. Yep, you gotta give it a hashtag because it really deserves a hashtag. A lot of time when we do stoichiometry, we have to use hashtag mole ratio. Mole ratio is really key. This is why we love molarity, because we balance the chemical equation using moles. So mole ratio really matters. So far so good? Okay, so are you ready to do a practice problem, yeah, for stoichiometry? So don't forget that for me. I want you to remember limiting reagent, and I want you to remember mole ratio. All right, here is our first problem. We're going to do a lot of problems in this class, so make sure you get this down. 10.0 ml of hydrogen peroxide solution is titrated and found to be equivalent to 13.5 ml of 0.109 molar MnO4 minus solution. What is the molarity of H2O2 solution? Okay, what is the molarity of H2O2 solution? So far so good. And of course I'm going to give you a balanced equation. The balanced equation is I have 2 MnO4 minus plus 5 H2O2. This is a balanced redox reaction. Plus 6H plus goes to 2 Mn plus 2 and 5 O2 and 8 H2O. Sorry if my marker is about to die, that's why I'm reading it, so hopefully you see those. Okay, so far so good? Okay, so I have 2 MnO4 minus 5 H2O2, 6H plus, I'll use a different marker, 2 Mn plus 2, 5 O2 and 8 H2O. Okay, so that's what I got. I'm gonna use a different marker. So far so good for the coefficient. So you will see those numbers better. All right, beautiful. Let's do this together. You ready to do this together? Okay. So in this problem, you read this problem, you're probably gonna get nervous. It's like, oh my God, how do I do this problem? Sometimes you don't even need to understand the problem to do it. I mean, I want you to understand it, but numbers, and you know the formula, you can plug it in and then understand the problem. So you have a 10 ml of hydrogen peroxide that is titrated and is equivalent to 13.5 ml of 0.109 molar solution of MnO4. So one thing I know, that for MnO4 solution, I know the volume and I know the concentration. Do you guys agree? I know the volume and I know the concentration. So that's great. I'm going to write down the equation that I know, and that is molarity is equal moles per liter. You know molarity. You know molarity is moles per liter. Write down what you know. Do you know the molarity of MnO4 minus? Yes, you do. Do you know the volume of MnO4 minus solution? Yes, you do. If you have the molarity and you have the volume, can you figure out the moles? Yes, you can, right? Okay, so I'm going to plug this in. The molarity was 0.109. I don't know the moles, but the volume was 13.5 ml. Molarity has to be moles per liter. Dilution doesn't matter as long as both units matched up, but this one has to be liters. So I have to convert that to liters, divided by 1,000. I get 0.0135. So now, if I solve for x, I get 0.00147 moles of what? MnO4 minus. Are you guys okay right now? Okay. So I knew that MnO4 minus, I had the concentration and I had the volume, so I could figure out the moles. I got the moles of MnO4 minus. But the question does not ask you for MnO4 minus. What does the question ask you for? The question asks you for hydrogen peroxide. Every time the question gives you one thing, but they ask for something else, what you have to use is hashtag mole ratio. So every time they give you one thing, but they ask for something else, we did this in Chem 1A, you have to use hashtag mole ratio. Okay? So I have 0.00147 moles of MnO4 minus. I don't want the mole of MnO4 minus. What do I want? I want the moles of hydrogen peroxide. Okay? So to do that conversion, to convert the one to what I want, I need hashtag mole ratio. How am I going to find out the mole ratio? Coefficients are the mole ratio because we use moles to balance the chemical reaction. Coefficients are the mole ratio. So look over here. I know my marker wasn't good, so hopefully you can see it. There is 2 MnO4 for 5 hydrogen peroxide. So that's what you got out of the balanced equation. Coefficients are the mole ratio. I want you to repeat after me. I know I can't hear you, but do it anyway. Coefficients are the mole ratio. So if I do this, now what I get 0.003679. That's the moles of hydrogen peroxide. So now I have the moles of hydrogen peroxide. But again, that's not what the question asked me for. What does the question ask me for? For concentration of hydrogen peroxide. Well, what is concentration? Concentration is moles per liter. Do I have the moles of hydrogen peroxide? I do. Do I have the volume? 10 ml. I do. So I can just plug it in. So molarity for hydrogen peroxide is going to be the mole, which is 0.003679 over the volume, which was 10 ml. I have to convert it to liters. So 0.0100 liter. If I do that, I do have to care about sig fig, don't I? Don't forget the sig fig. With 3 sig fig, it will be 0.368 molar. Sig fig, one of those things that you want to forget about it, but you can't. So this will be the molarity of hydrogen peroxide. This will be the molarity of hydrogen peroxide. How do you guys feel about this? Not bad, right? Not too bad. I just want you to remember the stoichiometry that you use, and also don't forget the mole ratio. The mole ratio is what I want you to remember. All right, let's do one more practice problem, and then next time we're going to do a lot more practice problem. But I want to do one more. Before I let you go, and then we'll do some hard ones next time too. I mean, these were also hard. It's a good way to start. All right, so I'm going to make sure you get the basics down before we get a little bit fancier. Before we get fancier, just make sure you get the basics down and you remember your Chem 1A for me. All right, here is my next one. solution A was prepared by dissolving 15.0 grams of NaOH in water and diluting to a final volume of 225 ml. Okay, question A. What is the molarity of A? Question B. 15 ml of A is diluted to 740 ml. What is the molarity of this new solution? Okay, you ready? So this is to remind you of Chem 1A stuff. It's good to always practice. Now, if you read the first question, you go, okay, this is not bad. They're asking me for molarity. And I know what molarity is. Molarity is moles per liter. Molarity is moles per liter. Now the problem is, so molarity is moles per liter, but I don't have the moles here. Do you agree? Okay. But could you figure out the moles? You could figure out the moles. Because what they give you the grams of the solute. So when you have grams, can you convert it to moles? Totally. How do you go from gram to moles? You use molecular weight. And molecular weight is always for 1 mole. So 1 mole of NaOH is 40.0 grams. So far so good? Okay. And again, don't forget to cancel out. So then the grams can cancel out and I end up with moles. So what I get is 0.375 moles. I'm going to come over here. Do I have the moles now? I do. 0.375 moles. Okay. Do I have the volume? Remember, this is moles over liters of this solution, so the final volume. What's the final volume? 225. Is it the right unit? No. You have to divide it by 1,000 to get it to liters, so 0.225 liters. So moles divided by the volume. How many sig fig? I know we gotta care about sig fig. I'm limited to 3 sig fig. What I end up getting is 1.67 molar. And if you remember, if you want to be cool, you can try to be cool. You don't say 1.67 molarity, you say 1.67 molar. That's what cool chemists call it. Yeah, so that will be the molarity of this solution. Okay, next part. It says 15 ml of A is diluted to 750 ml. What is the molarity, the new molarity? Remember, every time you change in the concentration, what is the equation you're going to use? M1V1, M2, V2. Every time you change in the concentration, you have to use M1V1, M2, V2. Every time we're doing dilution, we're changing the concentration. That's what we have to use. What is my initial concentration? You have it. Is 1.67 molar. Okay. What is my final concentration? That's what I'm trying to figure out. I don't know what my final concentration is. Okay. What is my final volume? It is diluted to 740 ml. So my final volume is 740 ml. Okay. What is my initial volume? How much of 1.67 do we take? We take 15 ml of it. We took 15 ml of it. Okay. You gonna follow me so far? Okay. That's not too bad. So I can figure out my final concentration. 2 sig fig, it would be 0.034 molar. This is kind of to remember your Chem 1A stuff. Huh? All right. Beautiful. Really, really nice job. What we're going to do next time, we're just going to keep doing the stoichiometry and concentration problems. What I want you to remember, sometimes we may give you a unit that is not what you want, which what we want is molarity. So we can find ways, cancel it out to get to the unit that we want. And a lot of times, once we get to the unit that we want, we have to do dilution because it's cheaper to buy more concentrated solution and then do dilution. Now, one last thing I want you to remember before you watch the next video with more practice problem. The one thing you have to remember from Chem 1A is titration. You gotta remember for me what titration was, the concept and the calculation. So I'll send you guys another video for titration just to remind you what titration was in Chem 1A, and then we'll go from there. Nice job, nice job. Survived the first one. I'll talk to you guys next time.